Okay, there are a couple more properties of functions we want to go over. And the way it works is first you look at something and determine if it's a function or not using the vertical line test. Then once you know it's a function, you start looking at all the other properties, like evaluating functions like we were doing last time, and now finding what's called the domain and the range. As far as it goes, the range, there are tricks to find it, but generally speaking, you have to use the graph to do that. We're going to do that later in the semester. So for right now, we're going to discount that and not worry about it. And we're only going to focus on the domain. As far as definitions go, you can get really technical with your definitions, but for the purposes of what we're doing, for the domain, we'll just say all the x's you put in. And for the range, we'll say all the y's you get out. Again, as far as the range goes, the best and simplest way to find the range is to look at the graph. We're going to deal with that more later in the semester, so for right now, we'll just not even worry about that. And we'll just focus on the domain, all the x's you put in. So we started before with the equation of a line. F of x equals 2x plus 3. What's the domain? It's all the x's you can plug in. If you think about it, no matter what number I plug in for x, I can multiply that number by 2, and then I can add 3 to it. It doesn't matter. Any number I put in here, I can still multiply by 2 and add 3. So any number will work. So I just say my domain is all real numbers. Every real number will work. Suppose I have quadratic, because we dealt with those. F of x equals x squared. Again, if you think about it, I can plug in 0. 0 squared is 0, so that's fine. If I plug in any positive number, I can square it. That's fine. If I plug in any negative number, I can square it and get a positive, and I'm fine. So any x will work. So again, my domain is all real numbers. And the problem is, if you just focus on these, it begins to look like all real numbers is a domain for everything, and then it doesn't really matter. So we're actually going to look at functions whose domain are not all real numbers and see tricks we can use to figure out what the domains actually are. As far as it goes, there are two main issues that arise finding your domain. For the first one, suppose we have f of x equals 1 over x. Right away, it should be obvious that I can't put any number in there for x. If I plug in x equal to 0, I get 1 over 0, which does not work, because I can't divide by 0. Which means 0 can't be in my domain. So then, maybe the domain for this, we'll say the domain is all real numbers, except x equal to 0. Or if you want, there's different ways to write this. You can say the set of all x such that x is unequal to 0. The different ways to write it, I'm okay with you writing it different ways, as long as you correctly find the domain. Suppose we have f of x equals 3 over x plus 6. Here, if we plug in 0, like we did last time, we're completely fine. We get 3 over 6, which is a half. So 0 is in my domain. But there's still a problem. If I plug in negative 6, I get 3 over negative 6 plus 6, which is 3 over 0. And then again, we can't divide by 0 and we're out. So now, maybe my domain is the set of all x's such that x is unequal to negative 6. Ultimately, we can look at more complex functions. We'll do one more complex looking one in a second. But essentially, the first problem that can occur is when you have a fraction with an x in the denominator, like here and like here. And once you have an x in the denominator, there's the possibility, if you plug in the wrong number, you'll have division by 0, which doesn't work, which means that number can't be in your domain. So all you really have to do is, if your function has a fraction with an x in the denominator, take the denominator and set it equal to 0. Whatever x's make the denominator 0 are the x's that can't be in your domain. So one more example of this. Suppose we have f of x equals 2x plus 1 all over 3x minus 5. I want to find the domain. Right away I know that there's an x in the denominator, so there's the possibility that some x will cause a problem. So take your denominator and set it equal to 0 and see what x is, make it 0 and cause a problem. Add the 5, you get 3x equals 5, divide the 3, you get x equals 5/3. Which means if I plug in x equal to 5/3 into this, that will become 0, and I'll be dividing by 0, which I can't do. So then what's my domain? The set of all x's such that x is unequal to 5/3, the x I found. And there we go. As far as it goes, that's all you have to do. If you have a fraction with an x in the denominator, set the denominator equal to 0, and that will tell you the x's that can't be in your domain. There's one more problem we want to go over that can pop up. Suppose we have this. F of x equals the square root of x. That's certainly a function. What's the problem? I can certainly take the square root of a positive number, not a big deal. I can take the square root of 0, not a big deal. But I can't take the square root of negatives. I know complex numbers have negative square roots and all that. For the purposes of this, our domain, we only care about real numbers. So I can't take the square root of a negative. Which means in this case, my domain would have to be something like the set of all x's such that x is greater than or equal to 0. So then, maybe suppose we have f of x equals the square root of x minus 4. It should be obvious that if having an x inside of a square root caused a problem here, there's a possibility it will cause a problem here. But we can use a similar trick to what we did with the first problem with fractions and x as the denominator. I can only take the square root of something greater than or equal to 0. So take whatever is inside the square root, x minus 4, and make it greater than or equal to 0. And then solve that. Add the 4 and you get x is greater than or equal to 4. That's my domain right there. Those are all the x's that keep that greater than or equal to 0, which means those are all the x's I can use for my domain. If you want to write it out formally, the set of all x such that x is greater than or equal to 4. Once you do that, well then, suppose we want to make it more complicated. Say we have f of x equals the square root of 2x plus 7. But the idea is the exact same. Take the square root. Since there's an x inside of it, there's a possible problem. So take whatever is inside the square root and set it greater than or equal to 0. And then solve that. Subtract the 7. You get 2x is greater than or equal to negative 7. Divide the 2. X is greater than or equal to negative 7 over 2. Those are all the x's that if I plug them in here, the square root will be greater than or equal to 0. So that's my domain. Again, to write it formally, the set of all x's such that x is greater than or equal to negative 7 over 2. As far as it goes, those are the only two problems we really have to worry about. Having a fraction with an x in the denominator, and having a square root, a radical, with an x inside of it. There are lots of ways you can combine those. You can have square roots and fractions and all of that all thrown together. You'll get to mess around with some of that for your homework, but ultimately it doesn't really matter. It boils down to, if you have a fraction with an x in the denominator, set the denominator equal to 0 and solve. Those are the x's that aren't in your domain. If you have a radical with an x inside of it, take whatever's inside the radical, set it greater than or equal to 0, solve that. Whatever you get is your domain. As far as it goes, that's all we really need for this class to find our domains. Like I said earlier, we'll deal with the range later on.